Hi there, this is video 1.3. It's on inductive reasoning, and we're going to use inductive reasoning and do some more math type questions. So we got our handy dandy steps, which says one, either analyze the data, or sometimes you have to generate data. Look for the pattern, make your rule. I forgot the part. I look for pattern and make a rule. Whoops, conjecture. Get the right word. All right. And then see if the pattern works and check a couple more examples. It sounds really complicated, but it's not. All right, we need to do the product of two odd integers. Okay, and remember product means multiplication. So I need to multiply two odd numbers. So 3 and 3 gives me 9. Now I could sit here and do this. 5 times 5 is 25. 7 times 7 is 49. Now I can get a bit of a rule from that. Based on that, the product of two integers is always a perfect square, but you don't want to limit, you want to, what's the word, broaden your options. So don't just multiply the same number by itself. All we got to do is make sure they're odd. So we can do 3 times 1 is 3. See, it's not a perfect square anymore. The more data you have, the better your conjecture is going to be. 7 times 9 is 63. Now, for what it's worth, that says integers. If you remember, integers are positive and negative numbers. So minus 5 times 7 is minus 35. Minus 1 times, I don't know, minus 7 is 7. Okay, that's more than enough. Usually when you're doing an assignment, I say, give me at least 3 examples. So we got a whole bunch there. And what do you notice about all the answers, all the products? They are all, when you look at them, they're all, the products are odd. That's it. It's not more complicated than that. Now, see if the pattern works on more examples. Well, we did a whole bunch there and kind of ran out of room. But is there any two odd numbers you can multiply together where you're not going to get one? Right? Well, what if I used 99 times 101? What if they're really big? Now I need my calculator. One 99 times 101, 9,999. Okay, so yeah, it's not happening. We're done. There is my conjecture. And the process we just did is inductive reasoning. So the process of inductive reasoning, the rule you make is your conjecture. Right, how about you try the product of two even integers? So try to pause the video. All right, let's try it. 2 times 2 is 4. 6 times 8 is 48. 10 times 20 is like 200. So I did a nice pair. I picked ones that are different. I'm using some bigger numbers. Oh, integers. Minus 6 times minus 4 is 24. Minus 4 times 10. Just trying to come up with a mixture. Minus 40. Okay. That's, I think, enough. What can you say about all those answers? Exactly. They're all even. Sorry, my dog is destroying a tennis ball. I just want to check on her. The differences of consecutive perfect squares. All right, so difference is subtraction, and consecutive is one after another. I think it's the next couple videos from now, we go through all the vocabulary. So it's like 1, 2, 3, 4. Those are consecutive numbers and perfect squares. So 1 squared minus 2 squared and 3 squared minus 4 squared. And let's go 5 squared minus 6 squared and 20 squared minus 21 squared. All right, so 1 minus 4, 1 minus, so I did the consecutive, I just set it up, and now I'm going to go through. So that's minus 3. So we got 9 minus 16, that should be 5. 25 minus 36. 25 minus 36 minus 11. 21 squared. All right, so this is 400 minus 441. And so that's going to give me minus 41. All right. We could say they're all negative. Okay. I guess if we go in order, that certainly makes sense. So they are, number 1, you could say, actually, let's just do a really good answer and cover it all. They are negative and odd. There we go. So the difference of consecutive perfect squares are negative and odd based on the information we did there. All right, now, sorry if you can hear some rattling in the background. That's just my dog destroying a tennis ball. Sum means to add, and difference you already know is negative. So again, I'm going to ask you to turn off the video and try those 3 questions. All right, let's see. Sum of an odd and even integer. So odd, so we go 5 plus 10. And 5 plus 10 is 15. Let's go minus 7 plus 12. That's going to give me 5. So I'm looking, because it says integer, so I need to try a few negative ones in there. Minus 8 plus minus 3 minus 11. So it doesn't matter. Oops. Well, you're adding, so it doesn't matter. But you know what? I don't like this example. Minus 3 plus minus 8. I know it's the same thing, but it said to add an odd and an even. So let's do it in the order it said. What else we can do? 15 plus 2, 17. We got enough? You guys make a conjecture. Right. Sum is odd. Done. Sum of 2 odd numbers. Okay, so 3 plus 5 is 8. 9 plus 21 is 30. And I'm just picking these numbers, just random. So these ones were kind of like one after another. These ones are far apart. 19 plus 1. So small one, big one, small one, big one. Now let's go big one, small one. 20. I don't even know what other options we can make. I think I've got enough. What do you say? The sum is all right, the difference of 2 even numbers. So 10 minus 6 is 4. 20 minus 2 is 18. Now, it didn't say anything about order, so what happens if we go put 2 minus 12? Minus 10. What if we use 200? Minus 100. All right, you get with this, the difference is always, yeah, the difference is even. All right, so the more support you have for your conjecture, the stronger it is. However, you can never be sure it is true because there might be examples you haven't thought of. You have, oh, let's go, not checked. Right? I'm just going to go back to, where was it? Oh, this one, it's the very first one. Oopsies. Can't see that anymore. Right? So when I was doing product of two odd integers, if I would have stopped with just these examples, I would have got an answer that said always going to have a perfect square. But when I did more examples, I was able to say that all the products are odd. So the more support, the more examples that you go through, the stronger your conjecture is going to be. But inductive reasoning is not great because at some point there may be an exception that you haven't thought of. And that's the end of that one.